Hello and welcome to this series of videos from Stromlearn, and we're going to be looking at circle theorems. So there's 7 circle theorems that you need to know for the GCSE course. This video is going to look at the first 3 of them. Okay, so the first circle theorem states that the angle subtended at the centre of the circle is double the angle subtended at the circumference. And that's represented by this diagram on the left. So we can see here, if the angle at the circumference is x, then the one at the centre is 2x, so it's double the angle at the circumference. And you can do that either way around. So you can say the angle at the circumference is half the angle at the centre, or the angle at the centre is double the angle at the circumference. The important thing in applying this circle theorem is that if we look at these 2 points here, the angle that is made at the centre and the angle that is made at the circumference come from the same 2 points on the circumference. Okay, so let's have a look at this example and see if we can use it to find the value of x. So we have an angle at the centre, 230, and we're looking for an angle at the circumference, but we can't just half the angle that we've got in the middle. That doesn't work, and the reason it doesn't work is because although we have an angle at the centre, it's not the correct one. It's this one that I've just marked on we're looking for. So how am I going to find that? Well, I'm going to start by doing 360 subtract 230, which gives me 130. Okay, and that's because I know that the angles around a point have a sum of 360. Now I know that angle x is going to be half of that, which in this case is going to be 65. Okay, so here are some questions that you can try to do with that theorem. It also throws in a few things about some more basic angle rules, so knowing that the angles in a triangle add to 180, knowing that base angles in an isosceles triangle are equal, knowing that a triangle made with 2 radiuses of a circle are going to be make an isosceles triangle, things like that. Okay, so here are the answers. And then we're going to move on to circle theorem 2. So circle theorem 2 tells us that the angle in a semicircle is a right angle. That's basically the angle that we just, the rule we just looked at, but a special case of it. So this right angle here is 90 degrees. But if we think about the angle at the centre, that angle at the centre is 180 degrees. Here we've got the 2 lines meeting, and here we've got the 2 lines meeting. So it's the same conditions as were set out in the last circle theorem. Is just a special case of it, and you can state this special case just to save a bit of time. Okay, so let's look at this example. So we have a semicircle. The angle in the semicircle is a right angle, so this angle here is 90. We then have a triangle. We know the angles in a triangle add to 180, so we know 65 plus the 90 plus the x is 180. So that gives us 155 plus x is 180. If I subtract the 155, x is 25 degrees. And there we go. And here are some questions with that circle theorem and the answers. And then we move on to circle theorem 3, and that states that angles in the same segment are equal. So to remind you of what a segment is, if you can't recall that from work you've done previously perhaps on circles, I've drawn in there a chord. And that term chord is for a line that connects 2 parts of the circumference with a straight line. Now a segment is the area on one side of a chord. So this is the relevant chord here, and that's because this is where my lines are coming out from. Here and here is where they meet at each end. Now the reason I've drawn it at this end rather than doing it at the top, because clearly the same applies at the top, is because the x's are at the top, so I'm interested in the chord at the bottom. Okay, so you can see that these two angles are the same. They're angles in the same segment because from either end of the chord I've drawn them to touch the circumference, and they've both gone above the chord, so they've both gone into the same segment. I mean, it would be equally true, say if I drew one like this would also be x, and I can do that as many times as I like. Now this circle theorem works because if I was to draw an angle at the centre, the angle at the centre is double the angle at the circumference, so that's 2x, and we can see that this angle x up here or this angle x up here, they both meet that the conditions for that first rule, so they both must be half the one in the centre, which means they're both x, which means they're equal to each other. So it's just a kind of a shortcut to having to use that rule as an intermediate, the first rule as an intermediate step. And that's why these three have been collected together, because they're all really derivations of that first one. So let's look at applying it to this question over here. Okay, so I know that angles in the same segment are equal. So this angle here is x. I could say that this angle over here is x. Or I could think about it the other way up, and if I think about this chord I've just drawn in here, then the angle 35 is equal to this angle because they're angles in the same segment, so that's 35. Now one thing which is a good tip really for angle circle theorem rules, and this kind of goes for pretty much all angle questions, if you're not really sure what you're doing from the beginning, just start working anything out you can, and before long you'll find a way that works, because there's so many different ways you can do these questions. So if I was looking at that left triangle, I've only got two of the angles, but I could get this missing angle because I know vertically opposite angles are equal, so it's opposite the 100, so the 100 is equal there. So I could have formed a triangle on the left hand side and worked with it, or one on the right hand side. Now the one on the right hand side was less effort, and now I can just state that those three angles add up to 180. And that gives me then x is 45 degrees, and we're done. And here's some examples from that circle theorem. And here are the answers.